All right, everybody, welcome back. Today we are going to be talking about single replacement reactions. So just a quick review of what that means. The word replacement means to substitute or change one thing for another. So like trading partners. Perhaps you're in a relationship and not quite happy with your significant other, and you choose to replace that significant other with a new one. This is the basis of a single replacement reaction. To give you a real life example, if me and Mr. Bazicki are together and Mr. Fishback really wants to be with me, doubtful, but just saying, he would probably beat up Mr. Bazicki and then I would have to marry Mr. Fishback. Again, not something I'd be very happy about, but since he is stronger than Mr. Bazicki, would most likely be the case. So the same thing happens with chemicals. So in this case, if one element is stronger, and what stronger really means is that it's more reactive, so it's more likely to react with another element, is stronger than another, then what ends up happening is it boots one element out of its relationship, which really is its compound, and forms a compound with that other element. So for example, zinc here is actually more reactive than copper, so zinc will actually replace copper in this reaction. And then your products are copper alone, since it got booted out of its compound, and then zinc and chlorine now form a compound together. And that's how this happens. So if we look at the single replacement worksheet, you're going to notice at the top of the worksheet there's a bunch of fill in the blanks. So those fill in the blanks are going to come from the single replacement notes, which I'm going to go over right now. And then at the bottom, there's some activity series worksheets to do, and then some other things for you to do as well. And we're going to go through that in a few minutes. So let's look at these single replacement notes. Again, these are the notes at the top of the worksheet. Okay. So basically, a more reactive element replaces a less reactive element. So if you look on the right side here, you'll see that there are a bunch of metals and also some halogens, which are non-metals. And it gives you the order of reactivity. So towards the top are the most reactive, and towards the bottom would be the least reactive. So we've kind of talked about this before, but gold is very unreactive. It does not like to react with anybody. That's one of the reasons it's used for things like jewelry, because it doesn't actually tarnish or react with oxygen. The same for things like platinum. Now, if you go to the top here, you'll see lithium, rubidium, potassium. These guys are super reactive. They will pretty much form a compound with anyone. So keep that in mind. Metals can only kick out other metals. So a metal can replace a metal, but they can't replace a non-metal. So you can't have like two metals forming a bond. It just doesn't work that way. And if you want to get into the details of that, send me an email and I'll explain all that to you further. Halogens can kick out halogens. Elements cannot kick themselves out, so they can't like boot itself out. That doesn't make any sense anyway, right? So the question is, will these reactions happen? So when we look at single replacement reactions, I want to know, can this reaction happen, right? If I'm mixing chemicals, I want to know, are these things going to react or are they not going to react? That's important for me as a chemist. That should be important for you, right? If you're mixing stuff together, you want to know if something cool is going to happen or if it's just going to be, right? Nothing happens. So if you look here, we have calcium and silver chloride. So what I'm going to do is I'm going to look up calcium. Here it is, okay? And actually, if you want me to, I'll even highlight it for you. Woohoo, right? Let's use the technology. And then I have silver. Excuse me. All right. Now, if calcium is stronger than silver, then then the reaction will happen. Yes. Because calcium's way up here and silver is way down here, it is stronger indeed. So when I write down what's going to happen, I'm going to put yes. This reaction is going to happen. Woohoo. Right? Pretty simple, yes. Now, if I look at the opposite reaction, if I try to mix some regular silver with some calcium chloride, since silver is so much lower than calcium and much less reactive, it is not strong enough to break up this couple. Okay, so no, this reaction is not going to happen because that silver is not reactive enough to push calcium out of its bond. Okay. If I look at number 3, notice calcium and calcium chloride. Again, I told you cannot boot yourself out, right? So no, nothing's going to happen if you mix calcium and calcium chloride. Don't believe me? Go ahead and try it, okay? I promise you nothing will happen. Now I'm going to go down and do another example a little bit lower down. All right, here's iodine and then potassium fluoride. Now I'm going to look up iodine down here in the halogens. Iodine is way down here at the bottom. Okay, and fluorine is way up here. Fluorine is very, very strong. Right? It's one of the most reactive elements, but it's the most reactive halogen for sure. So since fluorine has a really strong bond with potassium, iodine cannot kick it out of this bond. Iodine is very weak, right? So no, this reaction is not going to happen because iodine is much less reactive than fluorine. It cannot boot it out of its relationship. Now, a lot of people will end up putting, F and I together, but you cannot do that. So iodine cannot replace potassium either because they're different types of elements. They're a metal and a nonmetal. Okay, so keep that in mind. So if we go back to the worksheet, excuse me. All right, there's a few examples that I did for you. There's plenty of other examples to try on this worksheet. And for these ones, you really only have to write yes or no. When you give a reason for this, you can simply put calcium is more reactive or less reactive. Make it very simple. It doesn't have to be super complicated. Okay. When you go down here, you're going to tell me if these reactions are synthesis, decomposition, or single replacement. So we're kind of combining the stuff we did yesterday and today. Right? Just the name of the type of reaction is fine. And then down here, all right, you're going to try to predict the products. This is a little bit more tricky, okay? But what you really want to do is you want to tell me what the two products are going to be. So when this reaction happens, who's going to bond with who? Be careful because when you look at number 2 here, you're going to notice that it's chlorine is the single element, which means that chlorine is going to look to replace bromine, not sodium. Okay, so keep that in mind. I would like you to try these out and submit them. If you guys do that, then at the end of the week, I will post an answer key so you can see if your answers are correct, and I will correct your answers for you as well. Again, do as much as you can do. Please feel free to send me a private message or an email if you feel like you need a lot more help doing these. And have a great rest of the day.